What happens if our sensors only have 2 or 3 wires on them? We've explored photoresistors, Hall effect sensors, and brake beams. They each needed simple circuits to connect them to the Arduino. Inertial measurement units, or IMUs, are more complex. They use micro-electromechanical devices called MEMS. These are only micrometers thick. They need additional circuitry to amplify and filter the small signals they produce. The gyroscopes, accelerometers, and magnetometers are put onto an integrated circuit or chip. They have components on them that help produce a usable signal. Option 1 is to buy this chip from a retailer by filtering and finding one that fits our needs. If we found a dip version of this chip, we could use it to prototype in a breadboard, because it already has connecting pins attached and it's properly spaced. Most of the ones we will find will be surface mount. These require some tricky soldering and a custom circuit board. In either case, we're going to have to make our own circuit by using the datasheet. We'll find the pinout diagram, and that will tell us what each tab does. Luckily, we have a second option. Companies like Sparkfun and Adafruit do all the work for us and have ready-made breakout board solutions. These are more user-friendly for hobbyists and allow us to integrate the sensor directly into our project. Instead of soldering the tabs, we are now able to solder the header pins to the breakout board and place this in our breadboard. Sparkfun and Adafruit have tutorials that help us understand the components, teach us how to wire the circuit, and implementations for the breakout board. They typically provide documentation about the board and the chip, including their own schematics and the datasheets for the components. In the datasheet, there's a block diagram that shows the accelerometers and the magnetometers on one sensor block together, and the gyroscopes are in a separate one. On the pinout diagram on the next page, the gyroscopes are represented with a G, the accelerometers with an X, and the magnetometers with an M. Sparkfun and Adafruit provide location and descriptions for these pins on their boards and diagrams for wiring them. On the board we use, the top 6 pins are for communication. We can choose the Serial Peripheral Interface, or SPI, or the Inner Integrated Circuit, or I2C. They are different communication protocols. SPI uses more wires to communicate, but does it at a faster rate, since it sends and receives data at the same time. I2C is slightly slower and only needs 2 wires. You can use whichever protocol works with your circuit. The top 4 pins are for SPI. CS means chip select. This allows the program to choose between the gyroscope block, represented with a G, and the accelerometer magnetometer block, represented with an XM. SDO is Serial Port Data Output, which is the line that the data is sent out from. SCL is the serial clock line, and it synchronizes the data sent between the Arduino and the breakout board. SDA is the data line for the information being sent from the Arduino to the breakout board when in SPI mode. When using I2C, we only need the SDA and SCL lines. SDA becomes a 2-way data transmission between the breakout board and the Arduino. They take turns sending and receiving information, which is why it can be slightly slower. The SCL again keeps the data synchronized between the 2 boards. Future videos will expand upon these communication methods. Then we have our power and ground pins. The bottom pins are all interrupts and we won't use them, but they can be turned on in the program. Interrupts stop the program from proceeding down its checklist of tasks in order to immediately do something else, no matter where it is in the program. Now that we have the circuit all wired, we can move on to the code. They both provide example Arduino sketches and libraries. The Arduino sketch for the board basically says, print out all the values for the gyroscope, accelerometer, and magnetometer. Libraries are a way to reuse code and keep the sketch simple. All the cumbersome work is done in the library files. There's a .h file, which is your header file, and this outlines what your library will accomplish, and it sets up the basic parameters. The CPP file is the implementation file, and it specifies how your program will run. You don't have to do any coding in these files. You just need to add them to your local libraries. You can manage your libraries from inside the Arduino IDE. If you install a library that provides examples, you'll see new examples in your drop-down menu. The provided sample sketch for our Sparkfun IMU board is well commented, but we wanted to give you a basic overview of what the sketch is doing. At the top, the SPI and wire libraries are included. These are commonly used libraries for setting up communication between the Arduino and an external device. Even if you're using the I2C version, you need to add the SPI library because the SFE LSM9DSO library, which is the IMU library, calls it out, and it will not work properly without it. The sketch then defines the connection type between the breakout board and the Arduino. You need to comment out one of these protocols that you're not using. You can choose between printing out raw values from the sensors or values that are calculated and scaled. These calculations will occur in the implementation file. You can choose the frequency at which the program prints out the values. And now that everything is defined, we can move on to the void setup loop. The serial communication is initiated, and notice the baud rate is not our typical 9600. Then the library is initialized and some error checking is performed. The void loop sends the program to 5 functions. Print gyro is the name of a function. There's nothing in the parentheses because it sends and receives no information outside of the void loop. Since the function doesn't return anything, void is placed in front of it. Inside of the print gyro function, it calls read gyro. Read gyro is another function, but it resides inside the implementation file. This is followed by an if-else statement. It says if print calculated was defined above the void setup, then it prints out the calculated values from the implementation file for X, Y, and Z. Else if print raw was defined above, it's going to print out the raw values for the X, Y, and Z. The end if just ends the statement and we exit the function. The program goes back to the void loop and is told to go to the print accel function. The accelerometer and magnetometer functions work the same way as the gyroscope function. The heading and orientation do not need to pick from calculated or raw values. This is why they are sent a float type variable. These are values from the magnetometer and accelerometer sensors. Inside their loops, they calculate and print the heading and orientation. If you're not ready to create your own boards or libraries, breakout boards are a perfect alternative. Typically, you just have to solder on the header pins, then use their provided wiring diagrams and download their libraries, and you're ready to go. Because of Google's Making and Science team, today we were able to learn about breakout boards, functions, and libraries. You can check out more science content using this hashtag sciencegoals. If you have any questions or comments, you can leave them down below or find us on other social media. You can support us at patreon.com/scijoy, and remember, keep exploring.